Good morning, students. 11th class. Today I am going to explain the one example of numerical based on Ostwald dilution law. This law meant for ionization of weak electrolyte and also help us in calculation of degree of dissociation of any kind of weak electrolyte. So the question is, calculate the degree of dissociation and concentration of hydronium ion in 0.01 molar solution of formic acid. The constant or the equilibrium constant for this acid is 2.1 10 raised to power minus 4 at 298 Kelvin. So the acid given here is formic acid. What is formic acid? The first carboxylic acid is termed as formic acid, which contains only one carbon atom. So this acid is formic, is also a weak acid or weak electrolyte. So it will ionizes in water to produce the hydronium ion like this. Formic acid in presence of water ionizes to a partial or small extent because this acid ionizes in presence of water to produce respective hydronium ion and formate ions. HCOO negative are termed as formate ions. In this case, equilibrium is set up between these ionized ions and this unionized formic acid. So the constant is called as Ka. We have to calculate the degree of dissociation. Suppose alpha is the degree of dissociation of this formic acid. Alpha is the degree of dissociation. So according to the concentration concept, we know that this formic acid dissociate to produce hydronium ions and the formate ions. So the initial concentration of this formic acid was given to us is 0.01 m. M stands for molar concentration, means number of moles dissolved per liter. So initial concentration of these product ions will be equal to 0. When this equilibrium is set up between this ionized and this unionized electrolyte, so we obtain the equilibrium concentration, and that will be equal to 0.01 into 1 minus alpha. This is the degree of dissociation, means number of moles of this particle dissociated from the total number of moles. So the formation of this hydronium ion will be equal to 0.01 alpha, and concentration of this formate ion is also equal to 0.01 alpha. So the alpha is very small as compared to 1, therefore it can be neglected. Hence the overall equation for this Ka becomes equal to 0.01 alpha multiplied by 0.01 alpha, means concentration of product divided by concentration of reactant. Concentration of product ions, that is 0.01 alpha 2 times, and concentration of reactant means formic acid, which is equal to 0.01. Now on solving this equation, we obtained 0.01 alpha square becomes equal to K. This term is cancelled out. Therefore, the overall equation for this dissociation of the acid is equal as K. A is equal to 0.01 into alpha square. Now putting the value of Ka from the given statement, that is 2.110 raised to power minus 4, to this equation. Now it becomes equal to alpha square 0.01 is equal to 2.1 into 10 raised to power minus 4. This value is given to us. From this equation we can calculate the value of alpha square. Now alpha square is equal to 0.1 10 raised to power minus 4 divided by this term 0.01. This comes out to be 2.1 10 raised to power minus 2. Now from here we can calculate the value of alpha. Now alpha becomes equal to under root 2.1 into 10 raised to power minus 2. Therefore this becomes equal to 0.14. Hence The concentration of hydronium ions can be calculated as the concentration of hydronium ion is given to us is 0.01 into alpha, that is 0.14 multiply 0.01. This 0.14 is the value of alpha which we put here, multiplied by concentration 0.01. Therefore it comes out to be 1.4 10 raised to power minus 3. This is the concentration. Therefore the units for this concentration of hydronium ion is moles per liter. Hence, in this way we can calculate degree of dissociation or degree of ionization of any electrolyte, as well as we can also calculate the concentration of product ions. Next is the various concepts of acids and bases. Concepts of acids and bases. So we have four different concepts of acid and bases. First of all, we will discuss about the classical concept of acids and bases. We have also discussed about this classical concept in the previous classes. So according to this classical concept, acids and bases can be defined as the substances whose aqueous solution possess following properties. Means we have taken the aqueous solution of acid. Suppose we have taken mineral acid HCl, means hydrochloric acid, sulfuric acid, nitric acid, phosphoric acid, etc. When their aqueous solution is taken, their aqueous solution possess following properties. They will conduct electricity if the aqueous solution of the substance given to us conduct electricity, or which can react with reactive metals like sodium, potassium, magnesium, zinc, etc. When acid reacts with these reactive metals, then they always produce a gas named as H2 gas. अगर property show करता है substance, it means given substance is acidic in nature. Next is these substances turns blue litmus paper into red, and they have sour taste. The taste of the acid will be sour, and we will taste only the taste of organic acid. In this case we will taste only the organic acid such as citric acid, lactic acid, tartaric acid, etc. We should never taste the inorganic acid. The acidic properties of this acid will disappear. The acidic properties of acid will disappear when they reacts with base, because acid with presence or in presence of base undergo neutralization to form salt and water. So these are the properties shown by the given substance called as acid. Similarly, bases are those substances whose aqueous solution possess the following properties. They also conduct electricity. Next is when they reacts with or when they are tested with red litmus paper, the paper changes into blue. When we test the basic nature of any base with red litmus paper, the red litmus paper changes to blue. This indicates the given substance is basic in nature. In taste, these substances are bitter. They have bitter taste and they are soapy or slippery to touch. These substances are soapy or slippery to touch. Next is the basic nature of the substance also disappear when they combines with acid, because again they form salt and water. This is called as neutralization reaction. Next point is, so on the basis of this concept or this conceptual definition, further the three different concepts of acid was given, named as Arrhenius concept of acid and bases, then Bronsted and Lowry concept of acid and bases, and last one is the Lewis concept of acids and bases. So according to the second concept of acids and bases, which was given by scientist named as Arrhenius, so this is called as Arrhenius concept of acids and bases. According to Arrhenius theory of ionization, Arrhenius defined that acids are the substances which contains hydrogen. Acids are the substances which contains hydrogen, and when dissolved in water they produce hydrogen ions. So I repeat again, according to this Arrhenius concept of acid, on the basis of his popular theory named as Arrhenius theory of ionization, acids may be defined as substances which contains hydrogen, and when dissolved in water they gives hydrogen ions. Such substances are called as acid according to this Arrhenius concept. For example, we have taken hydrochloric acid HCl. Now it contains hydrogen, and when dissolved in water it produces hydrogen ion and chloride ion. Clear? Similarly, if we have taken nitric acid having formula HNO3, now it also contains hydrogen. When dissolved in water it again produces hydrogen ion along with nitrate ion. Similarly, sulfuric acid also consists of hydrogen atoms. So when dissolved in water they also produce hydrogen ions along with sulfate ions. So according to Arrhenius, all these substances are considered to be acid. So the dissociation of the respective substances into H ions is complete dissociation. Therefore these three substances will considered as strong acid. Therefore they are named as strong acid. Now the acetic acid acetic acid, then carbonic acid and phosphoric acid means H3PO4. These substances also consist of hydrogen ion, but in this case the dissociation is not complete. We have also discussed in the previous topic that the weak electrolyte or weak substances do not undergo complete dissociation. They shows only dissociation to small extent. इस केस में dissociation जो है वो small होगा. Clear? Now in this case the reaction can be written as, in presence of water the respective weak electrolyte dissociate to produce acetate ion as well as H ions. But in this case equilibrium is set up between these ions dissociated and this undissociated or the unionized electrolyte. So these type of compounds or these type of species will be considered as weak acid, because in this case dissociation is not complete. Similarly, a base is defined as a substance. According to Arrhenius, base is defined as a substance which consists of this hydroxyl group. OH means which consists of hydroxyl group, and when dissolved in water they produce respective hydroxide ions. In that case, that species which consists of hydroxyl group, when dissolved in water they produce hydroxide ion. Such type of compounds are called as bases. Similarly, again we have two different categories of bases which undergo complete ionization or complete dissociation, and second is which shows only small ionization or small dissociation. Therefore the subspecies which undergo complete dissociation into respective hydroxide ion, they are called as strong bases, and which undergo dissociation to small extent, these species are termed as weak bases. They are named as weak bases. For example, sodium hydroxide. Next is potassium hydroxide. When dissolved in water, they produce respective sodium ions as well as hydroxide ion, and this potassium hydroxide produces potassium ion as well as hydroxide ion. Therefore, the dissociation in these two cases will be complete. Therefore, they are strong bases. While bases like ammonium hydroxide, calcium hydroxide, magnesium hydroxide, aluminium hydroxide, etc. in this case dissociation takes place to small extent, and as a result equilibrium is set up between the dissociated ions and the undissociated substance. Therefore they are called as weak bases. Example is, suppose we have taken ammonium hydroxide, in presence of water undergo dissociation to produce respective ammonium ion and the hydroxide ion. But in this case, a fast equilibrium is set up between these ions and this substance. Therefore, these type of bases are termed as weak bases. And in aqueous solution, these hydrogen ion and these hydroxide ions, they will exist as hydronium ion. The H positive ions which are present in the acid as H positive, but in actual it is present as H3O positive because the proton or the H positive combines with water to form H3O positive. In this case, the molecule undergo hydration, means addition of H positive to water molecule, resulting in formation of H3O positive. So this dissociated H positive combines with water to produce hydronium ion. This is called as hydration process. Similarly, this hydronium ion again combines with water to form H5O2 positive. Similarly, again in presence of water, this H5O2 positive combines to form H7O3 पॉजिटिव एंड सो ऑन. इस तरह से पार्टिकल जो कंबाइन करेंगे प्रोटॉन्स के किसके साथ, वाटर के साथ, एंड रिजल्टिंग इन फॉर्मेशन ऑफ रेस्पेक्टिव ion. This process is called as hydration, or more simply the H positive can be written as H3O positive aqueous. H3O positive aqueous. Similarly, the OH ions in aqueous solution also combines with water molecules to form spaces like H3O2 1 negative, again undergo addition of water resulting in formation of H5O3 negative, undergo further combination with water molecules to form H7O4 negative. So more simply we can write it as OH aqueous. It is written as OH aqueous. Clear?